Okay, 3.4 is on partial fractions. Okay. So let's look at a problem here, a calculus problem, an integration problem, okay, where we have basically a polynomial over another polynomial, okay, p of x over q of x. Okay, x squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x. Okay, okay, dx. Okay, in order to solve this, we have to break this up using what's called partial fraction decomposition, okay, or PFD. Okay, so the first thing we need to do is we need to factor the denominator. So let's factor the denominator, and let's use partial fraction decomposition to help us break up the terms of the denominator. Okay, so this is x squared plus 2x minus 1 all over. Let's factor the denominator. Let's factor out an x. And I get 2x squared plus 3x minus 2. Okay. X squared plus 2x minus 1. This becomes x times okay. This is going to be 2x and x. Negative 2 is negative 1 and 2. And so I need to know where does the negative 1 go and where does the 2 go? Well, if I do 2 times 2, that's 4. And if I do the minus 1 here, when I FOIL it out, I would get 4 minus 1, which is the 3 that I'm looking for. So that's the correct factorization. Okay. That's kind of the guess and check method. You can do, factoring by grouping as well. There's many different ways to factor that. Okay, now, one thing that I want to note is that the numerator, okay, is a lower power than the denominator. So this numerator is an x squared, and the denominator is an x cubed. Okay, so we're not going to divide. We're just going to break this up using partial fractions. Okay, if the numerator was bigger on top than the denominator, I have to do division, long division of polynomials first, and then I'd have to use partial fractions on what's left over. Okay, but because the numerator is smaller power than the denominator, then we just have to break this up into different partial fractions. Okay, so let's talk about how to do the partial fractions. So I'm gonna take x squared plus 2x minus 1, the whole thing, all over x times 2x minus 1 times x plus 2. Okay? And this is going to be equal to a over x, something over x, plus b over 2x minus 1, something over 2x minus 1, and then c over x plus 2. Okay, and in this case, the a, b's, and c's are going to be constant because the numerators are always one less power than the denominators. Okay, if I have a linear function on the bottom, then we end up with a constant function on top. Okay, we can have a constant function on top. Okay. Okay, one less. So we have to account for the fact that they're one less power, which means they're going to be one less level, I guess, of complexity is the way that you could say that. You know, it basically steps down, you know, one power. X, the first, is just x, and then this will go to the x to the 0 term, which is a constant term. So here A, B, and C are constants. Okay. Okay, so how do we find out what A, B, and C are? Well, there's a couple of techniques that we can do. There's an algebraic technique of grouping like terms. We could group like terms. Or we can do something called the Heaviside technique. And we'll start with the Heaviside technique, named after Oliver Heaviside, who was a physicist. Okay. There's a lot of overlap between physics and mathematics. Okay. Einstein was a physicist, but he developed a lot of mathematics as well. Okay. Kind of keep developing math so they could do the physics. Newton as well. He was a physicist and needed math to do more physics, so he just invented calculus. Okay, x times 2x minus 1 times x plus 2. I'm going to clear the denominators on both sides here by multiplying through by x times 2x minus 1 times x plus 2. Okay, what's that going to do? It's going to allow me to clear this side. So I just left with x, that's an x squared plus 2x minus 1. Okay, now when I distribute these, I will get an a over x times 2x minus 1 times x plus 2 plus b over 2x minus 1 times x times 2x minus 1 times x plus 2 plus c over x plus 2 times x times 2x minus 1 times x plus 2. Okay, now I'm going to cancel what they have in on the numerator and denominator in common. So the x gets canceled there, the 2x minus 1 gets canceled there, and the x plus 2 gets canceled there. Again, I keep forgetting the squared. Okay, so we have x squared plus 2x minus 1 is equal to a times 2x minus 1 times x plus 2 plus b times x plus 2 plus c times x times 2x minus 1. Okay. Okay, any questions on what we've done so far? Pretty straightforward. I just clear the fractions. Okay, so now we're going to use the Heaviside technique. The Heaviside technique only works if you have all linear factors. It only works if you have linear factors. We'll do more of these and find out what happens if you don't have linear factors. You'll have to do a different algebraic technique. But the Heaviside technique is kind of cool because we're trying to make things 0. Okay, here we have all linear factors. X is a linear factor. 2x minus 1 is a linear factor, and x plus 2 is a linear factor. So we can use what's called the Heaviside technique. Okay, for all linear denominators or linear factors, we'll say. Okay, so the first thing I'm going to do is I notice that I have an x here and an x. And so what I'm going to do is I'm going to let x equal 0. Because if I let x equal 0, the b and the c term, they go away. They cancel out. They're gone. So I'm going to plug in a 0 on the right side and on the left side. So let's plug it in on the left side. That's 0 squared plus 2 times 0 minus 1 is equal to a times 2 times 0 minus 1 times 0 plus 2 plus b times 0 times 0 plus 2 plus c times 0 times 2 times 0 minus 1. Okay. So notice that the b times 0, well, that's just 0. So the b term goes away. This becomes 0. The c term also becomes 0. On the left side, we just get a negative 1. On the right side, we get a 0 minus 1. So that's a times negative 1. And a 0 plus 2 is 2. So we end up with negative 1 is equal to negative 2a. Divide by negative 2. And we're left with a is equal to 1/2. And we've solved our first constant. Okay, so a is equal to 1/2. I'm going to circle that. Okay, now what I'd like to do is I'd like to get rid of the a term. Okay, and the c term. And the a term and the c term, they both have 2x minus 1 in common. So what value will allow me to get 2x minus 1 equal to 0? What value, when I plug in there for x, will allow me to get 2x minus 1 equal to 0, so that I can just solve for the b? Let x equal what?
1/2.
1/2.
Yeah, 1/2, exactly. So if I let x equal 1/2, then 2x minus 1 is equal to 0. And if you don't see that right away, you can always just solve for x. You could toss the 1 to the other side, divide by 2, and we get, okay, x is equal to 1/2. Okay, so let's plug in 1/2 now into both sides. So this is going to be 1/2 squared plus 2 times 1/2 minus 1 is equal to a times 2 times 1/2 minus 1 times 1/2 plus 2 plus b times 1/2 times 1/2 plus 2 plus c times 1/2 times 2 times 1/2 minus 1. And again, these will go to 0. Oops, not that one. That one and this one will go to 0. And that will wipe out the a and the c. On this side, we get, on the left side, we get 1/4 plus 1 minus 1. Well, that's kind of nice, because that becomes 1/4. Okay, the a and the c are gone because we end up with multiplying by a 0, which is the whole idea of the technique. Okay, and so we end up with b times 1/2 plus 2 and 1/2. Okay, so 1/2 times 2 and 1/2, which is 5/2. So this is 5/2 times 1/2, which is 5/4. I'm going to multiply both sides by 4/5. And that's going to give me b equaling 1/5. So now we have b is 1/5. Okay, c. Let x be what, so that we can get c. We go back up here and look at c. C, the only thing that c does not have is an x plus 2. So c does not have an x plus 2, but a and b do have the x plus 2. So what number is going to get me the value that's going to cancel out a and b here?
-2.
Yeah, thank you, Ishan. -2. Thank you, Brenda. Okay, perfect. So let x equal -2. Okay. Okay, and so x plus 2 is equal to 0. Okay, so again, let's plug in -2 this time. -2 squared plus 2 times -2 minus 1 is equal to a times 2 times -2 plus 1, or sorry, minus 1 Okay, times -2 plus 2, that's going to go to 0. Okay, plus b times -2 times -2 plus 2, that's going to go to 0. Right? Plus c times -2 times 2 times -2 minus 1. Okay. Okay, so on this side, we're going to -2 times -2, that's +4. 2 times -2, that's -4. So those cancel, that's nice. Minus 1, so we get -1. Okay, okay, so this is gonna, the A is gonna go to 0, the B is gonna go to 0. We're just left with C. So this is C times -2 times -2, that's -4, minus 1 is -5. So -2 times -5 is 10. C divided by 10, and C is equal to -1/10. Okay, so again, the hardest part of these problems is honestly setting them up. Okay, so what does this tell me? This tells me now that x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x is equal to, okay, A was 1/2, so this is 1/2 over x, plus B, which is 1/5 over 2x minus 1, plus C, which is -1/10 over x plus 2. Okay. So this tells me that when I integrate, I'm going to be integrating, I'm going to bring that 1/2 in front. And so the 2 gets dropped down onto the bottom. So this is going to be 1 over 2x plus 1 over 5 times 2x minus 1 minus 1 over 10 times x plus 2 dx. Okay, so now we've got three separate integrals that we can integrate, which are nice. We can do a u substitution on these and use natural log, okay, to solve them. Okay, so let's break this up into three separate integrals. This is the integral of 1/2, 1 over 2x dx plus the integral of 1 over 5 times 2x minus 1 dx minus 1/10, well, integral of 1/10 times x plus 2 dx. Okay. Okay, so I can pull the 1/2 out in front. So this becomes 1/2 times the integral of 1 over x dx. Okay, plus 1/5 times the integral of 1 over 2x minus 1 dx minus 1/10 times the integral of 1 over x plus 2 dx. Okay, so the first one is just 1/2 natural log absolute value of x. Okay, that one's pretty easy. The next one we could do a u sub on. This is u is equal to 2x minus 1. Du is equal to 2 dx. Divide by 2. And so we get 1/5 times the integral of 1 over u du over 2. Okay. You can pull that 1/2 out in front, that becomes 1/10 times the integral of 1 over u du. And so this becomes 1/10 natural log of u. But what was u? It was 2x minus 1, so this just becomes 1/10 times the natural log of 2x minus 1. Okay. And so the other one here, we could do another u sub on. The last one, u is equal to x plus 2. du is equal to dx. Okay, so this just becomes negative 1/10 times the integral of 1 over u du. Pretty simple. So this is negative 1/10 times the integral, which is natural log of u. And so this is negative 1/10 times the natural log of x plus 2. And I'm going to put a plus c just so I don't forget. And then I'm just going to add these terms together. So this is going to become 1/2 natural log of the absolute value of x. Okay, plus 1/10 times the natural log of 2x minus 1 minus 1/10 times the natural log of the absolute value of x plus 2 plus c. Okay, and I might be able to use some properties of natural logs to clean that up. I would have to make sure that there's no domain issues if I clean that up. I could probably factor out the negative 1/10 and put the natural log of 2x minus 1 over x plus 2, using the properties of logs, but I would have to make sure that there's no domain issues. Okay, I wouldn't want to take the natural log of a negative number because it's just not allowed. Okay, but I'm going to leave it like that for right now. This would be fine to leave on an exam. Okay, in this form. Okay, you went through the whole thing of doing the partial fraction decomposition, and then you integrated. So after that, I'm just happy that you got to something that's integrated. Okay, you don't have to clean up the algebra per se after that. If I say integrate this, well, you did integrate it, so there you go. Okay, so let's do one where we are given something a little bit more complicated, a little bit more spicy. Okay. Okay, and so let's look at number 2 here. We have the integral of x to the 4th minus 2x squared plus 4x plus 1 all over x cubed minus x squared minus x plus 1 dx. Okay, what do we notice here is different in this case than the last case?
Bottom of the lower degree polynomial than the top.
Yeah, the polynomial on the bottom is a lower order polynomial, lower power than the top polynomial. Okay, and so what we're going to have to do here is we're going to have to do division. We're going to have to divide and do some long division. Okay, notice that the power of the leading polynomial, or the leading term, for the numerator is larger, so we have to divide. Okay, so let's do some polynomial division here. So we're going to put the x cubed minus x squared minus x plus 1 on the bottom, that's on the bottom on the outside. And then we're going to put this guy on the inside. Now, I take x to the 4th, and then I put plus 0x cubed. I have to take into account that every term is going to have a place value here. Okay, every power of x will have a place value, and so we must put in the x cubed term. Okay, minus 2x squared plus 4x plus 1. Okay, so now I have to ask myself, how many times does what times x cubed gets me x to the fourth? What times x cubed? What times this guy gets me this guy? What times x cubed gets me x to the fourth? And it's just x, it's 1x. I'm going to put it over the x column. Okay, and now I'm going to multiply x times this whole polynomial. So x times x cubed is the x to the fourth that I'm looking for. X times negative x squared is negative x cubed. X times negative x is negative x squared. And x times 1 is just x. Okay. So just like in regular long division from elementary school, we're going to subtract. In our world, it's called change the sign and add, because adding the opposite is the same as subtraction. I'm going to change the sign here. Okay, that becomes negative, that becomes positive, that becomes positive, and this becomes negative. Okay, so I'm going to change the sign here, and then I'm going to add. Okay, so the net result is going to be a 0 here, which is nice. That's what I want. Okay, x cubed here. Okay, a negative x squared, and then a 3x, and then I'm going to bring down this 1. Okay, so now I have to ask myself, okay, what times x cubed is x cubed? What times x cubed is x cubed?
Just 1?
Yeah, it's just 1. Thank you, Daniel.
Yeah.
Okay, it is 1. So we're going to multiply 1 times our denominator here, and we're going to get x cubed minus x squared minus x plus 1. Change the sign and add. Change the sign and add, and we end up canceling those guys out. Okay, get rid of the 0 for right now. Okay, canceling those guys out. We actually end up canceling these guys out too, which is kind of nice. And we get 3x plus x, which is 4x. And then we get plus 1 minus 1, which is 0. So my remainder is 4x. So how do I write my remainder? Well, I'm gonna write it as a fraction. This becomes 4x over x cubed minus x squared minus x plus 1, because that's the remainder. That's okay. We divided, and we got x plus 1 plus 4x over this denominator that I initially divided by. Okay, so this is what I really want to integrate on. So I'm going to integrate on x plus 1 plus 4x over x cubed minus x squared minus x plus 1 dx. Okay. Well, the first two terms are pretty easy. They just become x squared over 2, or 1/2 x squared, plus x. Okay, plus, I'm going to write this as its own integral. Maybe I'll pull the 4 out in front. 4 times x over x cubed minus x squared minus x plus 1 dx. Okay. Okay, so now I need to use, I need to factor the bottom. Okay, the denominator needs to be factored. Okay, so what is the denominator factored? What is this thing factored? X cubed minus x squared minus x plus 1. Let's factor that. I'm going to use factoring by grouping. So this is going to be x squared times x minus 1 times x minus 1. Factor out the x minus 1s. identical twins here, and we get x squared minus 1. Well, x squared minus 1, that can be factored as well. That's x minus 1 times x plus 1. So this actually ends up being factored into x minus 1 squared times x plus 1. Okay, that's the denominator factored. Okay. So we end up with 1/2 x squared plus x plus 4 times the integral of x over x minus 1 squared times x plus 1 dx. Okay. Okay. So now we just need to figure out, okay, what is this thing? And we're going to use partial fractions on this. Okay, so we have x over, oops, it's a big fraction, over x minus 1 squared times x plus 1 is equal to a over x minus 1 plus b over x minus 1 squared, we'll talk about that in a second, plus c over x plus 1. Now, why do I need an x minus 1 and an x minus 1 squared? Because x minus 1 squared is really, the denominator could take on two different scenarios. I could end up canceling out an x minus 1 and leaving me with just 1x minus 1, or I could end up with a constant over an x minus 1 squared. So I have to take into account that both of those scenarios, okay, could occur. If they don't occur, that's fine. A would be 0 or B would be 0. I would only end up with one scenario, but I have to account for the fact that both of those scenarios could occur. I could get, whenever you have a repeated root, okay, a repeated factor, you have to take into account that your denominator could have been a single factor, or it could be a double factor. Okay, so two scenarios here. Okay, now they're both linear factors. They're still linear factors, even if I wrote it like x minus 1 times x minus 1. Those are two linear factors. I just have to take into account that I could have one of them or both of them together. Okay, and so my constants here, if they exist, if they're non-zero, they are still going to be constants because they're all linear factors. X plus 1, right, was the third linear factor. It's x minus 1 x, but I do have a repeated factor here. And so I have to take into account that there could be two scenarios. Okay, again, if there's not, then one of these would be 0 or they would cancel out. Okay, unfortunately, in this case, nothing cancels out. So the two scenarios do hold. We have a value that has x minus 1 as the denominator, and we have a value that has x minus 1 squared as the denominator. Okay. I think I'm actually going to bring the 4 inside to make this a little easier, so that I don't have to multiply through by 4 at the very end. Okay, and cancel out a bunch of fractions. So I'm going to include the 4x on top. Okay. Okay, so now what we're going to do is we're going to multiply through by the denominators. Okay, we're going to cancel out these denominators here. And so if I multiply everything through, okay, by these denominators, by the denominator, okay, this is x minus 1 squared times x plus 1. If I multiply that through, I will cancel out and I'll leave the 4x on one side. The a, well, I would have canceled out one of the x minus 1s, but left one of them. And so this is a times x minus 1 times x plus 1. Okay. Plus b, here both x minus 1s get canceled out, and so I'm just left with the x plus 1. And then c, the x plus 1 gets canceled out, so I'm just left with the x minus 1 squared. Okay. Okay, so let's choose an x that will get us a 0. So what would be a good first choice here? Let x equal what? Yeah, 1. Let x equal 1. Okay, and that's going to give us some zeros. So if I do that, that's 4 times 1 is equal to a, okay, times 1 minus 1 times 1 plus 1 plus b times 1 plus 1 plus c times 1 minus 1 squared, right? And so this goes to 0. That goes to 0. And I'm just left with 4 is equal to b times 1 plus 1, which is 2. So 2b divided by 2. And we get 2 is equal to b, or b is equal to 2. Maybe I'll just flip that around. Okay, so we got b is equal to 2. That's the coefficient on the numerator of x minus 1 squared. Okay, what else could we plug in here? Well, we could plug in maybe -1. Let's let x equal -1. And that will get rid of the a and the b. So I'll get 4 times -1 equals a times -1 minus 1 times -1 plus 1. That's going to go to 0. Plus b times -1 plus 1. That's going to go to 0. Plus c times -1 minus 1 squared. Okay. So this is going to become -4. That goes to 0. That goes to 0. This is -1 minus 1, which is -2. Squared is a 4. So that's 4c. Okay, and so we divide by 4. And we get c is -1. Okay. Okay. So c is -1. So how do we solve for a? We've got b, we've got c. How do we solve for a? Let's go back to our original. Okay, the Heaviside technique fails us here a little bit because there is no way to get, there is no number that I can plug in for x that will automatically solve me for a. So I've got to look at this algebraically and do some algebraic manipulation. Okay, so let's look at our original 4x equals a times x minus 1 times x plus 1 plus b. But what was b? B was
It was 2.
Yeah, so let's plug that in. 2 times x plus 1 plus c was -1 times x minus 1 squared. Okay, so now we've got just x's and a's to deal with. So -1. Okay, so if I multiply this out, I get a times x squared minus 1. If I multiply x minus 1 times x plus 1, I get that guy there. Okay, this is plus 2x plus 2. Distribute this is going to be minus 1 times, just multiply out the x minus 1 squared. That becomes x minus 1 times x minus 1, which is x squared minus 2x plus 1. Okay, equals 4x. Oh, okay. Okay, so let's keep going with this. Let's try to clean this up. This is going to be ax squared minus a plus 2x plus 2 Distribute the -1, that's minus x squared plus 2x minus 1. Okay. Okay, so let's try to combine like terms. Okay, let's at least put the like terms next to each other and start combining some like terms here. So I will get 4x is equal to ax squared minus x squared. Okay. Okay, plus 2x plus 2x, that's 4x. That makes sense because we have a 4x here, we should have a 4x here. Okay, plus what are the constants? We've got 2 plus 2 minus 1, that's 1, minus minus a, right? So 1 minus a. Okay. Okay, and so if I factor out the x squared, I get x squared times a minus 1 plus 4x plus 1 minus a is equal to 4x. I'm going to put the a minus 1 in front. A minus 1 times x squared plus 4x plus, I'm going to group this just because I can, 1 minus a. And I'm going to rewrite this 4x a little bit differently. I'm going to use some zeros. I'm going to say that this is 0x squared plus 4x plus 0. And what does this tell me? This tells me that if I look at the terms and go term by term, a minus 1 should equal 0. 4x should equal 4x, and 0 should equal 1 minus a. So what is the value for a that makes this true?
One.
Yeah, 1. Yeah, thank you, Daniel. Yeah, 1. If I need a 0 in front of x squared, then 1 minus 1 is 0. And if I need a 0 for my constant, then 1 minus 1 is still 0. So this tells me that a must equal 1. Okay. Okay, now that we've done all the algebra, okay, we've done basically 2 pages of algebra, we can now go back and solve for our integration. The integration is actually pretty easy. Comparatively, we did, basically all of this algebra, okay, to get us back to here, where we can break this up into, we'll get us back to here, where we can break this up into certain integrals. Okay, now don't forget the fact that we already did some integration. We have 1/2 x squared, okay, plus x. Okay, and we want to break this up into the integral of a over x minus 1 plus b over x minus 1 squared plus c over x plus 1 dx. Right? Okay. So this is 1/2 x squared plus x. I'll put a plus there. Plus the integral of what? I'm going to break this up into 3 separate integrals. Okay. So I'm going to integrate a, but what was a? A was 1. So this is 1 over x minus 1 dx plus b. What was b? That was 2. That's the integral of 2 over x minus 1 squared. And then plus dx. That is a dx. Okay, plus c, which is -1 over x plus 1 dx. Okay. Okay, so now we're going to do some u substitutions here. Okay, so here u is equal to x minus 1, du is equal to dx. This is the integral of 1 over u du, which is the natural log of x minus 1. Well, it's the natural log of u. But what was u? Natural log of x minus 1. Here, same thing, u is equal to negative 1, x minus 1. Write that a little nicer. U is equal to x minus 1. Du is equal to dx. Okay, and so this becomes the integral of 2 times u to the negative 2 power du. That's just the power rule. So this is going to go up to negative 1 multiplied by negative 1. So this is negative 2 u to the negative 1, which is negative 2 over u. And so that becomes negative 2 over x minus 1. Okay. And then the last one here, u is equal to x plus 1, du is equal to dx. This just becomes the integral of negative 1 over u du. This becomes minus natural log of u. Okay, and what was u? U was, I'm going to put a plus c there, just so I don't forget it. Okay, and this is minus natural log of x plus 1 plus c. Okay, so now we have 5 terms. We have 1/2 x squared plus x plus the natural log of x minus 1 minus 2 over x minus 1 minus the natural log of x plus 1 plus c. And again, I could clean this up if I wanted to a little bit. I could just make this into maybe x squared over 2 plus x minus 2 over x minus 1 plus the natural log of x minus 1 over x plus 1 plus c. But again, that last step's not necessarily necessary. Okay, I just would be glad that you got the integration correct to begin with. Okay. Okay. If we look at the formula sheet, okay, we will see that on the formula sheet, we have a formula for inverse tangent, okay, that we can use. So if we go to here, and then I want to pull up the formula sheet. Actually, let me just pull it up this way. So again, calculus formula sheet. You will be allowed to use this formula sheet on the exam, so just keep that in mind. Okay, I would print it off and keep it handy, you know, maybe just keep it with you at all times. You never know when you're gonna need to work on your math homework. So just, you know, I don't know, carry it in your pocket 24/7. That's what I do. I'm just kidding. Okay. So here's my formula sheet. Okay, and the integral, number 18 here, the integral for du over a squared plus u, or we'll say u squared plus a, is 1 over a inverse tangent of u over a plus c. So we're going to utilize that property here in the next this value here. Let me maybe zoom. Can I zoom in? Let me zoom in a little bit here. Number 18. Our table of integrals up over, there we go. Okay, so this guy here, we're gonna utilize this guy in the next problem. Okay. So, yeah, so let me write that out. I'm gonna use x instead of u though, because we're utilizing the variable x. So for us, it's gonna be the integral of 1 over x squared plus a squared dx is equal to, okay, 1 over, okay, a times the inverse tangent of x over a plus c. And you can be like, well, where did they get that from? Where did this come from? Basically, what we do is we add and subtract, or sorry, we multiply both top and bottom by 1 over a squared. So if I were to multiply both top and bottom by 1 over a squared, okay, so I would go 1 over a squared over x squared plus a squared over a squared. What I would get is I could pull this 1 over a squared on the outside, and I would get 1 over x squared over a squared plus 1. Okay. Okay, dx, which becomes 1 over a squared times the integral of 1 over x over a squared plus 1, which is the inverse tangent on the inside here with a u substitution of 1 over ax. So this thing here, we would say, oh, that's u is equal to 1 over a times x. So what would du be? Du would be 1 over a dx, which would make what? Which would make a du equal to dx. And so when I pull this out, I'm going to get 1 over a squared times the integral of 1 over u squared plus 1 times a du, right? A du. Okay, so when I pull that a out, that's going to cancel with one of the a's on the bottom. That will leave me with 1 over a times inverse tangent, because this is inverse tangent of u, okay, plus c. Okay, and so, but what was u? U was x over a, right? So this equals 1 over a times the inverse tangent of x over a plus c. Okay, and so I kind of use that trick of multiplying top and bottom by 1 over a squared to get me this guy. This is going to be 1 over x squared plus a squared. So I kind of have to reconcile how to manipulate that a squared, and that will give me my formula. Okay, now, since I've already done this, I don't want to keep doing it over and over again, so I just memorize the formula. Okay, and then I can utilize that whenever I have the integral of something that's x squared plus a squared. I can utilize that inside my, I can just go directly from that to the inverse tangent, and I don't have to worry about, reinventing the wheel here. Okay. Okay, so let's do the last problem here, number 3. Okay, we want to integrate 2x squared minus x plus 4 all over x cubed plus 4x dx. Okay. Okay. Is the numerator smaller than the denominator? Yes, it is. So we're good there. Okay, I want to factor the denominator. So the denominator is going to get factored into 2x squared minus x plus 4 all over x times x squared plus 4 dx. Now, x squared plus 4 is not That cannot be factored anymore. Okay, so I just end up with the two factors here. However, this factor is a quadratic. It is not linear. So we have to deal with the fact that, you know, how do we deal with something that's quadratic? We've dealt with linear stuff up until now. Linear factors. Maybe they've had multiples of each other, but where they've all been linear. But now we want to deal with something that's a quadratic. Okay. So let's set this up. This is going to be 2x squared minus x plus 4 all over x times x squared plus 4. And this is going to be equal to a over x, okay, plus, now this is going to be over x squared plus 4, but we always have to go down one power. If this is an x squared, the numerator has to be linear, and it has to be a linear function. So it has to take into account any possible linear function that could exist. Now, any possible linear function that could exist could either be a constant function or it could be something that involves x. So we actually end up with two terms here on top. We have to take into account that we could have an x term, or we could just have a constant term, okay? So this ends up with, I'll kind of leave it like that, but it really ends up as a over x plus bx over x squared plus 4 plus c over x squared plus 4. Okay, I have to take into account that this thing could be any linear function I could come up with. Okay, so the numerator is always one less degree than the denominator. Okay, and we have to come up with a function. If I had a cubic in the bottom, I'd have to have ax squared plus bx plus c, or we'd have to have bx squared plus cx plus d, or something like that. Okay, bx squared plus cx plus d. Okay, we'd have to take into account all the possible quadratics that could occur if it was a cubic in the denominator, and then we'd have to do, you know, it for higher ordered functions as well. Okay, so and luckily we only have to deal with a quadratic here, which means that we just deal with all of the variables of a linear function, which isn't too bad. Okay. Okay, so let's use the Heaviside technique here. Well, I don't think we can. We can't use this Heaviside technique, but we're gonna clear the fractions anyway. So 2x squared minus x plus 4 over x times x squared plus 4. We do need to get figure out what a, b, and c have to be. So I'm going to multiply through by the denominator, x times x squared plus 4. Okay, so x times x squared plus 4. Okay, so cancel that guy. 2x squared minus x plus 4 is equal to distribute. Okay, this is going to become a over x times x squared plus 4 plus bx over x squared plus 4 times x squared plus 4 plus c over x squared plus 4 times x squared plus 4. Okay. Oh, there's an x there. Sorry. Okay. So now let's do some cancel there. cancel there, cancel there. And so I'm just left with a times x squared plus 4 plus bx times x, which is bx squared, plus cx is equal to 2x squared minus x plus 4. Okay. Interesting. Okay, so now let's kind of group these term by term powers of x. Let's group the powers of x. So let's distribute the a. So this is ax squared plus 4a plus bx squared plus cx. And that's about it, right? So that would be x squared. So now let's put the ax squared plus the bx squared together. Okay. Plus the cx plus the 4a. That's 2x squared minus x plus 4. 2x squared minus x plus 4. Okay, and let's see. Again, let me factor out the x squared. I'm going to get 2x squared minus x plus 4 equals, this is a plus b times x squared plus cx plus 4a. Okay, so now let's see what we can group here. Well, I know that a plus b must equal 2. Okay, so we've got the 2 and we've got the a plus b as coefficients in front of the x squared. I know a plus b has to be equal to 2. I know -1 has to be c. Okay, well, that's nice. So c is equal to -1. Okay, because those match up. Okay, and then 4 is equal to 4a. So what is a then? If 4 is equal to 4a, okay, so 4 equals 4a, then wouldn't a equal 1? Yeah, a equals 1. And if a plus b have to be equal to 2, then 1 plus b is equal to 2, then b is equal to 1. So we get c is equal to -1. Okay, and b is equal to 1 and a is equal to 1. Okay, so we're gonna get the integral of, well, let's rewrite this as just, this is gonna become what? We have a over x plus bx plus c over x squared plus 4, right? Okay, or we could do bx over x squared plus 4. We just do bx over x plus c over x squared plus 4. Let's just do that. Okay, so what is a? A is 1, so this is 1 over x. What's b? B is 1, so that's just x over x squared plus 4. And c is -1, so that's just -1 over x squared plus 4. Okay. So now we're going to integrate that, dx. Well, the first one is pretty easy. Let's break it up into 3 integrations. One over x squared plus 4 dx. Okay, and let's break this up into the first one's just natural log, right? That's just natural log of x. Okay, the second one is a u substitution, which is kind of nice. So this just becomes u is equal to x squared plus 4. Du is equal to 2x dx divided by 2. Okay, and so we get our x dx here on top. Okay, so this becomes the integral of 1 over u du over 2. Okay, so that's just 1/2 times the integral of 1 over u du, which is equal to 1/2 times the natural log of u. But what was u? Well, it was natural log of x squared plus 4. Okay, absolute value. Okay. Okay, what about the other one over here? Okay, the last one, what is that going to become? This is minus what? This is minus 1/2 times the inverse tangent of x over 2 plus c. Where did I get that one from? Yeah, we just did it before when I said, look, when you have something x squared plus a squared in the denominator and it's under 1, we already derived the formula for that. Okay, and it's number 18 on our formula sheet. So you can go directly to this. You don't have to derive that over and over again. It's an identity. So now what do we have? We have the natural log of x, absolute value of x. Okay, the x squared plus 4, can everybody understand that I can drop the absolute value bars because it's always positive? This thing's always positive. Okay, no matter what x's I put in, that's always positive. So this is going to be 1/2. But I'm gonna raise this to the 1/2 power. This is going to be the natural log of x squared plus 4 to the 1/2 power. Okay. Yeah, and then minus 1/2 times the inverse tangent of x over 2 plus c. Well, what is anything to the 1/2 power? It's the square root, right? So I can take this natural log of absolute value of x plus the natural log of the square root of x squared plus 4 minus 1/2 inverse tangent. I don't have to worry about x squared plus 4 going negative. So I can write it as a square root inverse tangent of x over 2 plus c. And then using the properties of natural logs, I can take this as the natural log of a product. So this is the natural log of the absolute value of x times the square root of x squared plus 4, absolute value minus 1/2 inverse tangent of x over 2 plus c. And that is the answer to number 3. And that is section 3.4 on partial fractions. Okay.